Okay, recording is going. Oh, hi, Felix. So we've got, in addition to LangTeam folks like Josh, Felix, Scott, and honorary LangTeam Mark, we've got Aman and Logan, who are part of the group that's been working on this implementation, if I'm not mistaken. And all right, let's start walking through. So for reference, this is the work to try to make closures so they don't just capture an entire variable, but they only capture kind of the part you're using. Turns out to be a little complicated. And we've run into some kind of questions we wanted to get LangTeam feedback on. But before I dive into those, I want to kind of walk through some of the details. And I guess we'll kind of approach them in reverse order in some sense. And like this is one of the biggest ones is kind of what is the correct behavior? So we have toyed with a couple different rules around what move closures ought to capture. There's some considerations. I'm going to go through the rules as currently implemented and then explain a little bit of why. So one thing that we realized along the way is we don't have, when you have a move closure the way that it's currently implemented, it does not capture through a deref basically. Meaning if you use star X, you'll actually capture X. And similar that, but if you used here, like in some, well, okay, in this case, there's a few reasons for this. One of the motivations is around boxes. If you're not careful, like if you look at this example, tuple is a pointer to a big structure. And here we're gonna capture a 4096 size array instead of capturing a pointer to that array. So in the rules as they are currently implemented, move closures are always capturing things, something that's already on the stack is being moved in, or some subset of something that's already on the stack. This also avoids things like capturing derefs of raw pointers, but that's kind of a no-brainer. In contrast, I guess this applies also, right, Aman, to any move. Is that right? Like even if it's not a move closure, but you do a move.
Yes. Yeah, that's like the second point in this.
Yeah. So if you're capturing by reference, then we can capture sort of through a deref, but if you're capturing by move, we won't. And right, by value captures don't capture derefs. Yeah, that's what this, okay, I see. Right, that's this point, is that this applies not only to move closures, but also to closures that are not move closures, but which move values. And pretty clearly, one thing we noticed, you can't capture through a raw pointer because that doesn't make any sense. You don't know that the raw pointer is valid at the time the closure is created in particular. One thing that I see, yeah, okay. I actually don't know what the repact story is. Aman, do you want to talk to that?
I think this was like things might not be aligned and the reads might not be safe.
I see.
Yeah.
Yeah. By the same token, like essentially anything that requires unsafe, we'll have to back up.
Exactly.
Something that we've considered but not implemented, I guess it's not in this like link list of things, is this extension around reborrowing, where the idea would be, and this actually was proposed on the original RFC. The idea would be that if you have let's say a move closure or just a closure that has a move, and the value, the full path is reached by going through an ampersand mute, then instead of moving s.x here, you would actually have a mutable reference. So you would basically have a mute ref of s.x and kind of reborrow it. So the contrast is the current rules that we've actually implemented, because there's a deref of s, they're going to capture s as a whole and move it into this closure. But under the proposed extension, what would happen is that this move closure would actually reborrow s.x. And the premise is that's kind of equivalent to moving it. Like if it's some data that you have access to via by reference, you're going to keep having access to it by reference. And that will rule out the use of S so long as the closure is live, just like a move would do. Well, unlike a normal move, you would get the access back once the closure no longer is live.
So this would be a narrowing reborrow, as in instead of having a borrow of all of S, you are now just borrowing S.x?
Yes, which means if you have S.y somewhere else, you can keep using it.
That is very much one of the motivating use cases for why I've been cheering on this RFC, yes.
Yeah, exactly. Now keep in mind, this only applies to moves. So like, I think this extension makes sense, but in the majority of closures, you don't have a move, in which case this is not a move. And in which case we would already be doing a mutable reference to s.x. It's only because this was a move closure, but all the uses were by reference that we kind of get into this situation. Does that make sense?
Seems reasonable for consistency to make sure that the behavior doesn't get worse when you move compared to better.
Right, and importantly, this rule still preserves, like the primary use for a move closure is to be able to return it from X or to have it escape the stack frame in which it was created. And this still works as well as it ever did. Like the closure can escape so long as it doesn't outlive this and mute S, which is an obvious requirement since which is true in both modes. Okay, any questions on the rules as implemented today? Okay, so let's talk about the migration plan. I think there are a few things that have come up. The first is that the obvious thing that was considered initially is that when you move different things into the closure than you originally moved, you might change when destructors run. Right, so if the closure would have moved an entire variable, but now it moves a more specific place. And if there are other fields of X that would have been moved before, but now won't be moved, and they happen to have a destructor that is significant in some sense, like the user cares when it runs, then that's going to change. And so what we're doing now is we're fixing that via a migration lint that inserts basically let X equals X, or let a tuple, some no-op like this that winds up doing the move of the whole variable so as to preserve the older semantics. And we don't want to do that for any destructor at all, because there's a good number of destructors that we think that just free memory in the standard library, and it's probably not what the user really wanted to move them in. They probably don't care when that destructor runs, and in fact might prefer it to run earlier, like at the point where the enclosing stack frame returns. So the plan is to, I don't think this is implemented yet, to allow an annotation that would be internal to RFC that can be put on to types or drops or whatever, drop impls, to kind of say, this is a non-significant destructor, which means that for the purpose of this lint, we won't insert a statement like this just unless if that's the destructor that's going to run at a different time. So this plan basically works, I think, modulo not having fully implemented the precise analysis, but there's a few kind of challenges. One is, this is let X equals X is sort of a effective hack, but this might be code that people have to write at other times, right? Like if you want to force when a destructor runs, you have to force a capture of X and not just the path you're using. And now this would kind of be the official way to do that. And that seems a little strange to me, like it looks like a hack. I think we have some similar things in closures today that I used to think were elegant, but after having seen people get confused a lot, I know I have revised my opinion from their elegant but still confusing. The classic example being you want to capture a clone of an RC, and the way I at least do that is to write this. But like I said, I used to think that was elegant because we didn't have any kind of, it didn't require any sort of special syntax for capture clauses or something. But most people don't seem to think of this, or if they do think of it, they think it's horrible. So I'm not sure that was such a good idea. I feel like this feels the same to me.
It's one of those patterns that works really well, but is not discoverable.
Right. And kind of
feels like maybe
it will always look weird.
Syntax would be good. Yeah.
When you see it, you'll always be like, oh, is that really what I'm supposed to do?
Is the proposal here to detect when other fields have non-trivial drops and only insert the x equal x at that point?
Yes.
If we know specifically what fields have a non-trivial drop, then rather than inserting a let x equal x, would it make sense to just insert a call to drop at the end? Rather than putting let x equal x at the beginning, could we put drop x at the end?
I was considering this, and the main objection I can think of is that that is a little bit heavy-handed in that you can imagine there's scenarios where the control flow means on some paths thing gets dropped and some doesn't, and let x equals x will handle that correctly, and an unconditional drop won't.
I see. So while it might potentially be more understandable, it would require the Rust fix to understand the code more and figure out if
you'd have to put the drops in all the right places.
Yeah, that's fair.
And there may not even be possible to do all the right places, actually, right? Like there's things that cannot be expressed by Rust code about conditional drop.
At least you would change behavior on panic, right? So that would be like one downside. Like you would need a. Like
would you?
I think you would, right? Because the drop X wouldn't run.
I don't think you would change behavior on panic, but you might change the order in which destructors run. The reason that, the reason I don't think you'd change behavior, you'd still be capturing it by move. And so if a panic occurs before you get to the drop X, it will get dropped, but it might be that it will get dropped in some different order because we captured x.y and x.z, but maybe the order in which they're in the closure is not the same as the order in which they're inside of X.
Yeah, that makes sense.
But I think the real thing is that, it's just, this is the only way to get exactly the same, or not the only way, but by far the simplest way to get exactly the previous behavior.
I mean, is the objection here just that this doesn't document what it's doing? Like, could you imagine a form, a syntax that's just like will drop X and it expands into let X equals X, but it's now saying outright like why it's there?
I think having had some time to sit on this, that I don't have an objection to this, and I wouldn't necessarily propose that we change it so much as that we consider for future, as a possible future extension, that there might be value in having an explicit capture clause syntax of some kind. I would want it to cover cases like this, and not only specify the things you move, but give you the ability to do some simple, like transformations that are commonly desired.
Yeah, I guess I'd like to better understand what the objection is. Like the code pattern you provided earlier, I'd like to better understand like what the objection is to that. In particular, to me, a capture clause that still is forced to occur at the beginning of the closure doesn't sound all that more palatable than what you wrote out. I can understand the objection being, I have to add this code that's nowhere near the use of the thing that I put in, right? Like that objection I can understand, but I don't think a capture clause solves that.
I think
for what it's worth.
Okay, go on.
I was just going to say, for what it's worth, my question a moment ago should not be taken as an objection to let x equal x. I was asking if there was a way to write it in a more self-documenting fashion, and it sounds like the answer may be no at the moment, but that I don't have an objection to that pattern. It's a sensible Rust fix.
So Felix, to answer your question, I think your right to press on looks odd is not a very specific specification, but I think for me, it's a combination of self-documenting and non-obvious, or rather not self-documenting and non-obvious. Like, I don't know that people will think to write it, and I don't know that they'll understand why it's there. A macro could help, but that it just feels, there is a certain part where it's hard for me to put my finger on it, but it feels hacky.
Yeah.
Uh,
The let x equals x I can see being pretty somewhat Baroque and not obvious. The x equal, I feel like I've seen the pattern of the clone, explicit clone before the closure enough to, you know, recognize it. So I find that curious that you found people who were confused. I'm not surprised people are confused by it. I'd be curious to know if there's veterans who are confused by it.
I think, I don't know that veterans are confused. I've definitely seen people not realize it was something they could do. And I've seen veterans say they don't like it. I think they get it. But
another thing I realized is if someone tries to do something similar, but they just use let underscore equals x just because x actually isn't. Actually, never mind. That would not work.
You mean if they try to do it? Yeah, if you write this, you might think you're doing the right thing, but you're certainly not.
Yeah, but it would also just
underscore.
Yes, but it would also just, the code will not work because then you just lose x, so that's fine.
Yeah. Well, I think even right now, this actually just is a no op, right?
Yes, it won't capture anything.
It has
So,
no
yeah.
change. It's not going to break the code. It just won't fix the problem you're trying to fix.
Yes.
So you're right. Also, I would say one other thing about the not obvious is that I could imagine that the idiomatic way, even if this is what the lint inserts, the idiomatic way to fix this might be to insert an explicit call to drop, because most of the time that will work fine, and it's much more obvious why it's doing what it's doing. Right. I also sometimes add explicit calls to drop when I wouldn't need to, just for that reason. Sorry, who?
Do we have some sense of how common, like as a percentage of like closure or something, this would be? And like potentially I could see us doing like we insert drop X if there is only one like exit path or something like that.
Yeah, that's a very good question. No, but we should, I think we can, we're getting close to the point where we could use Creator to figure that out.
The other thing that was curious to me here, the notion of marking destructors as not so important or whatever in a way. It's reminding me of that IRLO thread going on about talking about leak safety traits again and all this, or sort of the like, I feel like of most drops that are actually going to happen are going to be unimportant. So I don't know how best to deal with that.
Yeah, we had an epic discussion about this back with the static drop.
I was going to say,
RFC.
This is definitely shades of static drop, but I think the answer is yes, they will be, but it's hard for us to know when. I mean, you could imagine expanding this annotation so that users can add it too, if it were to like, and then kind of getting major crates to adopt it were important.
I haven't thought this through all the way, but is this is a spot where it's not just the type itself implementing drop, it's anything that needs drop, because the important destructor could be anywhere down the tree, right?
No, I mean, anything that we walk that recursively, so you have to reach a leaf that implements drop. That's basically the trigger.
Yeah, so just X not implementing drop isn't enough to say, oh, we don't have to do this, because it might be one of X's fields that implemented drop, and we still have to do that for this, right?
Yeah,
correct.
Okay, that sounds logical, but it's kind of a shame because it would be way easier to not have to do that. If it was just, oh, if you don't implement drop, then great, that would be so nice. But
yeah, I think that part works.
It would be nice, but it's not nice.
But it's not going to work at all.
Yeah. So there's another wrinkle, which is that there are other ways to change behavior that we didn't appreciate, or at least to have not change behavior so much as have an effect. One of them is, oops, I don't know what this links to. Looks like a broken link, but if you have an auto trait,
the one up below it, like around the end of the page.
this one here, yeah.
Yes.
So consider this example. I think Scott may have raised it. I don't remember, but we have here we are capturing. I think this comes out of code from the standard library. Actually, we're going to wind up capturing w.0 as a move because this is a move closure, and that's all stored on the stack. So we're going to capture w.0. However, w, which is basically f, which means that the type of this closure now includes f directly instead of including assert unwind safe wrapped around f. And the problem now is that assert unwind safe implements unwind safe, but f does not. So this code stops compiling. And that's super annoying. Like the whole
Oh yeah, I
reason.
raised that about clone.
Yes.
Yeah, there are lots of, this could happen with clone, which is not an auto trade.
Same and sync.
But it's same concept. This is much harder for us. Let me think. Well, yeah, it's harder for us to do the migration because we can't always tell who's gonna care, right? Like if you were to return this closure out from the function, it might be that like due to auto trait leakage and whatever, it might be that the callers care if it's send or not send, but we don't see that, and so we wouldn't really necessarily know if it matters. And so you don't want to have a test that's like if this type implements different traits than the type as a whole at all. That's pretty crude. You'd really want to condition it to only look at traits that might matter. I don't think we have a plan to fix this. I think we're just hoping it doesn't come up that much. But it's another case where you might want to write let w equals w that has nothing to do with dropping.
We at least have a chance of providing a good diagnostic in that scenario, something like this, to suggest let w equals w.
That's an interesting thought.
Might be able to see it in the sense that if we have a trait obligation fail within the closure itself, we can see if the root variable sort of implements that trait. So maybe that's a possibility.
I think we could do it. It wouldn't be within the. It would be if you saw a trait implementation of one of an auto trait or a clone or some such trait like that. I forget which exact set is, but these recursive traits.
Mhm.
And the self type is a closure. We could kind of do some stuff around it. I think we could implement a good diagnostic.
Actually, I have a question. Is this possible? Sorry, go ahead.
I was trying to figure out if is this only a problem for traits that are ever implemented for the closure themselves?
No.
Yes. No?
No, so like you can implement send and sync on so if you go back to, I think I have a link in there. Like you might implement send
Right,
and
but
sync,
closures can't be send and sync, right?
Yeah. Like when you have.
Wait, what?
So I think, can you go to 29?
Yeah.
And look at the comment that's at the very bottom. Yeah, so similar. So yeah, the closure won't end up implementing the trait, but
what?
I think
I'm not sure I understand what the question is. Maybe Scott, can you
So
rephrase
we
it?
never have a closure that implements hash, say, right?
Correct.
So this can never be a problem for the hash trait because anything that you were using inside the closure that cared about hash, it would still be capturing that part that was hash that needed to be hash. So this only affects auto traits and the other 2 or 3 things that we've defined on closures.
Correct. Yeah, auto traits and clone, and I think copy. I think that might be it.
I think copy's fine because the sub things are always copy if the closure was originally copy.
Yeah, correct.
So it makes me wonder if we just sort of have a special rule for auto traits that we don't break them up if they implement this auto trait and the fields don't or something, plus clone, and then we don't think about display or any of those things because they never matter.
Oh wait, I want
I see.
clarification about this.
Yes, you're right.
Are there scenarios where the whole thing implements hash and the smaller part doesn't, because the whole thing implements it in a specialized way that ignores the subfield?
Well, there might be, but you wouldn't sort of be able to observe it. Like the closure itself never delegates to its upvars.
Okay. The code within the closure would never encounter a case for this hat where that it gets hurt by this. It's only for things that, okay, like which is the same question Scott just asked. It's only for the things the closure itself needs to implement. Okay.
You're right, Scott. I hadn't really thought about the fact that it's a fixed set of traits, meaning that that we can sort of specialize this.
Yeah, I don't know how evil it is, but if it's just auto traits and clone, then maybe there's a way to say,
Yeah.
hey, look, your parts don't implement clone, so we're not doing this or something.
No, we could totally do that.
I don't know. I admit to being a little bit worried about changing behavior if you like change which part of your struct impulse clone.
Well, to be clear, this would be part of the migration lint, right? Not in the long term, not the way we.
Okay, yeah. If it's just part of the migration lint, then I'm more happy. I wouldn't want like language rules saying, I think, that the behavior of whether we capture the whole object depends on whether the field itself implements send or not.
Right. I assume Scott meant just for the migration lint.
I hadn't thought that far in either direction.
Okay, that's what I meant. I also
Great.
wouldn't want.
Sounds like a good plan.
I wouldn't want that the semantics either. I think there's a bit of a question mark here. I don't know if it's really a question mark. I guess we could see how often it comes up is all I was going to say. It's probably pretty unusual.
So many things are clone that.
Right. So many things are clone and so many things are send. I mean, in a recursive, simple way, right? It's unusual to override it, kind of.
Is there any weird? Well, I guess if you're passing, I can't imagine weird things of like you're implementing a vector and you're passing a closure to something while you're implementing the vector. So your clone starts cloning the pointers instead of the individual things or something, but I can't imagine any real code that does that. So
I'm not even sure I understand what you're saying. In fact, I'm sure I do.
The only place where clone gets funky is if the clone is not recursive. Like if vec starts capturing the length differently from the vec because you're actually looking at the fields of the vec, but that can only happen inside the vec implementation. So
I think the more potentially worrying thing is like if I have some struct and I'm cloning, I guess like I was thinking about like arc and RC where potentially you can clone like the arc itself or like the deref of the arc to some struct. But I think we would handle that correctly because there's not a field you can access that's the inner thing. You always deref to it.
Also, we wouldn't capture through deref.
Right.
The move. But I think, Scott, I'm still not entirely sure what you're saying because I think that anything in the body of the closure, like you're still accessing the same data that you ever were. So if you're doing explicit clones or something like that, it's just about whether you capture the whole struct or some parts of it.
Yeah, it feels like an edge case. I'm just trying to imagine some world where you clone your closure that had captured a vec by move, so you get a different pointer than if you captured the pointer inside the vec. And thus, when you cloned it, you got a clone of the original pointer instead of it used to be making you a new pointer when you cloned the whole vec.
Oh.
This is a scenario that only matter inside the vec.
I think I see.
Itself. Right.
So you're saying something like, I have a I don't know what I'm writing here. It's not Rust syntax, but ignore that. I have a struct like this, and I have a move, and you're saying like I had like so, and now the point is this used to run foo clone, but now it runs star mute u32
Yeah.
clone. I see. Yes, you're correct. There is a change, a subtle change in semantics there. What I did want to say about clone is that unlike auto traits, it doesn't leak. And so we actually can see all the places where clone gets called on the closure type, which is interesting. Like you could return an impl clone, of course, but and we could see that too. But so we actually could potentially make clone even more specific to say if you actually clone the closure. Because
and we have an attribute or something that derived clone sticks on derived clones, right?
We do. That's, I guess, for a migration lint, that's fine. Or
Yeah, I don't know if it's worth doing that or not, but
the changes to clone. Or capturing subpaths can change the semantics of closure.clone. That's a good catch. Thank you, Scott. I'm glad we drilled into that. Didn't understand it. That's not true for any auto traits. This is specific to clone.
Yeah.
Because it has like user-defined code that can run. Okay.
Well, I guess it potentially could be true if you somehow manage to write, like with specialization, it would become true for auto traits too, right?
Yeah, but yes,
But we
with
don't have that yet.
specialization, but we don't have it yet.
And hopefully the standard library doesn't ever make use of it in a way that matters.
Exactly.
Although, I guess technically, if you have like a closure that captures something and then the standard library currently, I guess we don't ever specialize on a closure type, so that shouldn't be a problem.
I don't think we'd use any specialization in any ways in the standard library that like introduce non-trivial changes to semantics.
There was a discussion once upon a time about specializing on like the less than for is sorted or something. That's the only one that I don't even know if that happened, but that's the only one that sounds like this kind of thing might care.
Yeah, the thing I would be more worried about is like, I don't know, for some reason, like you want to copy your closure a bunch of times, and then if you change what's inside the closure to a smaller field, now we compile that down to like a mem copy instead of not a mem copy, and somehow that, tanks your performance. But I am not terribly worried, I guess.
Yeah, I'm not too worried about that. But if we move to the other bug section, there's a similar problem that I'm more worried about. Is there more comments about? I guess we should discuss this bullet before we move on. But are there more things about this auto traits and so on interactions?
Is the main thought about the clone problem that we would just we would have a migration lint that tries to detect when you do this and say, I'm not even clear what we would say what you're supposed to do in response to this.
Let foo equals foo. I don't know. I guess I am not sure what. Well, so the fix would be to add let foo equals foo in the migration lint. That would preserve the older semantics. The question that is not entirely clear to me is how often to add that in. Do we want to try to get smart and only look for cases where you actually use clone? Do we just want to do it anytime that there is a clone that you could have used that is implemented by the user and not derived, something like that?
Yeah, I guess, I don't know, for a lot of these migration things, I am personally really interested in seeing like how often we even have to do anything. Like if, you implement no migration except or potentially even like no migration whatsoever, what percentage of crates break
Right.
with the new rules. And if it's like, I don't know, less than 1% or something, then maybe we don't bother too much.
Mhm.
But if it's like 50% of crates, then I'm more worried.
I also wanted to see data. I would love to think about those thresholds also. Like, I don't know whether 1% is a good one, but
Yeah.
The downside of this is each time we add it, I think there's a relatively small chance that you actually wanted it. And so, you know, each such migration, it just makes the code a little less idiomatic. So, yeah. Okay. On the other hand, tracking down the bug that results from clone running on the wrong thing sounds really unfun. So I wonder if never mind. I was going to ask a totally orthogonal question. Okay, this is another question. Right now in the implementation, if you have a subset, an index expression like this, we always treat it as if it was overloaded, which means that you would capture foo here and not foo of 0. And in the case where index is overloaded, that's sort of, we have to do that because you have to run the index code and it has to run on foo. By the way, there's some typing, so I'm gonna mute. There we go. Okay. Josh, yeah, you're muted. However, in the case where you're indexing into a fixed length array like this, we could choose not to do that. It would not be too hard, I don't think. So there's a bit of a policy question of like, do we want to specialize to known types and have more precise captures and then lose precision in the case of overloaded operators? We are doing that with deref, for example. Also in borrow check in various ways. So, or do we want to keep it consistent for index no matter whether you overload it or not?
We could plausibly relax the rules later, right? We would just need to either force a migration or wait till the next edition.
Correct.
Or actually, do we ever need a I guess there is some question if it's only for arrays. Does capturing only one of the elements, I guess it would change the order of destruction of the other pieces, right?
Correct.
Right. It would matter if you have a non-trivial destructor.
Actually, we may not even be able to handle
Yeah.
that, right?
We can't do that. We can't capture single elements of arrays. I'm pretty sure that was maybe in terms of drop semantics.
That's right. Yeah, we just can't because we would need a drop flag for every element of the array, and that's in the dynamic number of drop flags.
Yeah.
Right.
I guess we might be able to in this exact case of a fixed length array, but I don't think we do. So,
well, more, for that matter, would this how much would this matter in a case where what we're doing with it is not assigning it to underscore? Like in a non-trivial case, how much would it help?
yeah, very little, right? Because accessing the other elements of the array is still going to be disallowed. Like the borrow checker is not smart enough to know that foo of 1 is disjoint from foo of 0. So the only thing it changes is when the destructors run, but you won't get access to the rest of the array.
Yeah, well, and the size of the closure potentially significantly, but that's a separate question.
If we were trying to make this case capture less, one option would be noting that this isn't even using it as a place expression, it's using it on the right-hand side, and it's a copy value, which means technically you could just go retrieve it and then hold on to it.
Well, that's kind of exactly what we're saying. Like,
right, for copy kind of things, that could be right. The objection I had was about drop, but you can special case
right. If it's copy, you don't have to worry about it.
Is that true? Well, I don't. Maybe my brain is not working right now.
I
I
mean,
guess
there's the case of the overall thing being implementing drop, and the thing you're dereferring out, or the field you're accessing being copy, and that could be a
Right.
corner case here.
In this particular case, I guess that the element types are uniform because it's an array. So if any one element is copy, all of them are copy. So that is all true. But I don't particularly like the idea of making this different for copy or not copy, I have to say.
Like that could be an optimization.
Like if you add a T copy bound, I don't know, your closure captures change seems
I
wacky
feel
to me.
like, I don't know, I'm a fan of just capturing foo in this case. I think relaxing it is not going to increase the amount of code significantly that we accept in a way that like significantly matters in practice. And it does complicate the rules, and so it doesn't seem worth it.
And it seems consistent. The borrow checker doesn't have different rules for distinct indices, as you mentioned earlier. Like this is the same thing,
Yes.
right?
I agree. So it's consistent with the borrow checker. You wouldn't be able to access foo of 1 from outside the closure regardless. Oh, annoying. I guess the point is conceivably, if the element type were copy, we could handle this case differently, but that would be complicated and would mean that adding a T copy bound changes the behavior of your closures in significant ways, which is surprising. Are there other arguments brought up along the way?
I guess maybe to dig in a little bit, when you say change the behavior of your closures, I guess it doesn't necessarily feel true. Change the size potentially significantly, but not really behavior, and like especially with the
Changes
copy bound.
the capture set.
Yeah.
I agree that it's not going to change. Like we don't expect, because there are no destructors, you probably won't know. You'd probably be happy because you're copying less data in this particular case. Okay. Very good. Anything else? Well, I'm going to say conclusion, just capture foo. Oh, well, there was one other point. We could change this later over a future edition if desired.
Yeah, and I think we may even be able to get away with a change for like just T copy or something mid edition.
Right.
But I don't know. I'm not worried.
Me either. All right. So I should just close this, huh, man?
Yeah. More progress.
Yay. All right. It's the best way. Okay, the last thing, it's 50 minutes in, but the last point, which is fairly significant, is, or actually there's not much to say about this. I just want to call attention that the current implementation is not particularly smart. So it's possible that your closures get bigger. Is that true? Yeah, your closures could get bigger than they used to be because maybe before you just stored one reference to the entire struct, and now you have references to several of the structs fields instead. We did discuss on and off, like implementation optimizations, where we would try to just capture a closure pointer to the struct or whatever when we knew we could. We have not thought seriously about how to implement those. That sounds hard and scary to me. So this is something I would want to test and maybe get data on as well, personally.
And if we were to go back to capturing, oh no, if you're going back to capturing the whole thing, it would still have, because it's disjoint, it would still have to be some like special raw pointer future style or something. We could never just,
exactly.
Yeah, okay, never mind. I was about to go into a
like part of the beauty of the way,
but it doesn't match.
So the way it's implemented now requires like basically no changes to borrow check except for some that diagnostic patching for the most part, I think, because it's kind of just expressed in a way that borrow check can understand, which is nice. if we were going to add raw pointers, it would get scary. And I would be also worried about things like, I don't know, you use s.x, and if we capture a pointer to s and then s goes out of scope, I don't know, we have to make sure we get all the rules right.
Yeah. Avoiding that sounds great.
So I'm not too keen on that. It is some, I guess my recommendation at the moment is, yeah, we'll try to gather data and see what, like, we can print some warnings if closures get bigger by a certain percentage and see what we see in the ecosystem. And if it's a big deal, we'll think about it and decide what to do. Maybe we'll see some patterns or something that suggests itself. But we have
This
to actually gather the
phenomenon
data.
only arises in non-move closures, right?
Correct. With the current rules, yeah, because the move closures only capture some subset of what they captured before.
Right, the inflation, there can't be any inflation with move closures under the new rules. It's just
Yes.
with reference. Okay, just checking.
I think I knew that, and I even said it earlier, but I didn't fully think about it. I'm glad you brought it up.
Why does, sorry, I think I'm a little confused. Why does move closures not inflate the size?
Because at least with the current rules, I think this may change if we adopt that extension we proposed. But the current rules say that you only capture something that was on the stack already, basically. And so if before you were capturing the whole variable, which is all the things on the stack, now we're capturing some subset of those things.
Yeah, okay.
So,
okay, with the reborrowing, it will change, yes.
But yeah, the reborrowing, which we probably will implement.
Yeah, so.
Yeah.
That makes sense, Felix, the reborrowing.
Yes, that will now introduce new referencing kind of stuff, even on move closures. Yeah.
Yeah, okay. So the last thing, captures and matches. I think this is pretty much an implementation limitation that we hope to fix. But presently, when you match on something, for example, regardless of what's in the pattern, we're going to treat it as a use of the thing you matched on. And that means, like, here we would capture X even though we're not actually using any data from X. Also here, I forget, Aman, whether that's true for the let case or not.
Not for the let case, not right now.
Yeah, so we're a little bit asymmetric there between let and match, and that has to do with the way they're desugared and some annoying stuff around never types. Felix may have memories from NLL of trying to figure out how to make this an error, which we do by introducing a fake read of X that the borrow checker knows about currently, at least, which is why we have a problem, because there's a read of X.
So we are planning to make, like, line 1 in that first, that let underscore equal X, that is going to become a use of X.
Okay, so the current behavior, actually, I don't remember what the current behavior is. Aman, maybe you can clarify.
Current behavior is the compiler. It fails because it's an X right now. So wildcards are, yeah, pattern matching is a bug that's currently being fixed. But the idea is what we discussed at least last week was let underscore equals X will not capture anything. We'll just make sure that it will fake capture X is, I guess, the better way to put it. It will introduce a fake read of X just because when we do build MER, we do need, because let underscore equals X goes to the same pattern matching code as a match block does, we need a fake read of X. So we'll fake capture X so that we can support that. And same case goes for the match blocks as well.
So that's something we plan to do as an intermediate step, right?
Actually, can I interrupt? You mind, Nico, like turning them into, we're really talking about paths, like deref or paths there, right? Like X dot field, etc.
Yes, those could be.
It could be any path.
Yeah, it could be the whole thing.
The point is, the problem is in the compiler, there's places where we currently special case, like literally let underscore equals variable. It'd be good to make that clear that that's not what you're talking about here. It's only occurring to me just now because
Which place was that? Was that to do with the like the stuff you were doing on the in-place
Yes.
initialization?
Yes.
I sort of vaguely remember that. I thought, didn't we rip that out?
Well, all I know is we currently have, all I'm trying to say is I want to make sure we're clear. This isn't about like those special cases. This is about exactly the whole thing we're talking about here, which is
That's
arbitrary
right. It's not
expression.
about some special case like that.
Right. Every time X occurs there, we're talking about arbitrary expression. Fine. And then we'll
Correct.
process them as uses. Okay. Thank you.
So I think what your said, Iman, is, and I totally didn't remember this at all, but is that we plan to at all times make these let and match behave the same. But
Yeah.
for the moment, they will capture X, and we would prefer that they didn't.
Okay,
Is
so
that right?
so if we have, yes, we'll try to make them the same. If we have a pattern within a match, which is like if it's a multivariate enum, for example, and X, then we will have to capture X and stuff. Yeah, I think that's what
Yeah,
we think
right,
on.
right. Well, that's okay. Yeah, so the multivariate enum, just to give people context, we were observing that if you have something like this, you have to capture X because you need to read the discriminant of X to know whether it's some or none, even if you don't take any data out of X.
Yeah.
That's just kind of an implementation detail, but
yeah,
we'll get that right.
Yeah. Yeah, so I think the idea is, yeah, we'll try to not capture, have both of them behave the same way. That, yeah.
And I think ideally none of these would capture X because in no cases there are all irrefutable patterns and they're all not capturing any data. But we have to work through some implementation stuff there to make it happen.
It's going to be a little tricky on that, but yes.
All right, we have 3 minutes left. We're at the end of the doc, which is sort of beautiful. I planned it that way. Any final comments or thoughts, I guess, is the question. I think I would say, to jump back to our questions that we brought up, we settled we do not know, basically. We do not need a better syntax for migrations, but maybe we want to consider one or maybe not. That's just Nico. We came up with some ideas about how to migrate around traits that are not satisfied by the closure anymore. We can introduce migrations for these if necessary. We should measure. And this one I'm not sure, but I think there was consensus that our current, or nobody raised any immediate objections to the behavior as we specified it, and including the reborrowing extension. So if you do have concerns, think about it and tell me, either now or soon. Pre-stabilization.
I do think, I don't know, more generally, I feel like potentially if, 90% of closures gain a let X equals X type thing, then that is concerning. And then maybe we do need a different syntax or a different strategy here. But if we're expecting it to be low, then I think I would be less like, I don't know.
That sounds right.
I do want the data before sort of committing to no.
Agreed. No, assuming it's not that common. So I don't know that we can set a threshold here, but I think that's just like a good general rule, is to say there's nothing that's come up with any blockers so far, but we definitely want to run some crater tests, see how often these kind of edge cases and stuff come up, and that may cause us to revisit some of these questions. I don't know what a good number is for like the percentage, but maybe a better way is to say it is, what are some questions to try to answer? And it's basically like, what percentage of closures require let X equals X and Y? That's pretty much it, right?
Do we want to
I guess,
document?
Sorry, go on.
Just like in this question, there's something at the top about clone having interesting behavioral changes, just as a highlight in case.
Yeah, I'll put it here for clone. For clone, there may be changes in behavior, not just failure to compile.
Which Crater is not good at telling us or
Correct.
evaluating. So
Correct.
yeah.
Wait, Grader might tell us if their behavior changes, right? It runs the test suite, or
If there
does
happens
it
to be a test, yeah, it's just not a
guarantee thing?
yeah. It would be better if we are able to implement some code to report a compilation error in the case of a possible change in behavior, just to get an upper bound on what could possibly happen. Okay. All right. Thanks, everybody. We're at time.
All right. Bye.
Thank you.
Oh, there's something.